Welcome to AI Paper Podcasts. This is where we dig into the latest research papers, pull out the really important stuff, and break it down for you. Today, we're diving into a big one, GLM-4.5, Agentic Reasoning and Coding Foundation Models. It's from Zipu AI and Tsinghua University. Our mission, to unpack this new open source model series and figure out what it really means for the cutting edge of AI. Okay, so for everyone who just wants the super quick version, let's hit the key insights right now. First up, GLM 4.5. It's a new open source LLM using mixture of experts, MoE, and get this, 355 billion total parameters. But, and this is the clever bit, only 32 billion are actually active at any one time, so super efficient.
Exactly, and that efficiency doesn't seem to hurt its abilities at all. GLM 4.5 is built to excel across like three really critical areas. They call it ARC.
Agentic tasks, so interacting with tools, the real world, complex reasoning for tricky problems, and advanced coding. It's a big push towards more general AI. And the performance numbers are seriously pushing what we expect from open source. It has this thinking mode for hard stuff and a direct response mode for quick answers. Numbers: 70.1% on TAU bench for agentic tasks, a huge 91.0% on AMI 24 for reasoning, and 64.2% on SW bench verified for coding. Pretty impressive.
And looking at the bigger picture, that parameter efficiency is kind of a game changer, isn't it? I mean, way fewer parameters than many competitors, but it still ranks third overall among the models they checked, and number 2 on Agentic Benchmarks. Plus, they also put out a smaller version, GLM 4.5 Air, with 106 billion parameters. Yeah. Just shows you can get top performance without needing, a trillion parameters.
Right. And for all you AI researchers and ML engineers listening, this is super relevant. Both models, plus their evaluation toolkit, are open sourced. Hugging Face, GitHub, it's all there. So yeah, this paper isn't just tech specs. It feels like a real leap for open source LLMs pulling together these key skills. It could seriously speed up development and understanding, making general problem solvers more accessible. Okay, let's get into it. So when we talk about LLMs evolving, it feels like we're seeing this shift, right? They're not just knowledge banks anymore. The goal now seems to be general problem solvers, moving towards AGI, artificial general intelligence, models with human-like thinking abilities across different fields.
That's spot on. And this paper really leans into that. It identifies those three interconnected skills ARC as totally crucial for a generalist model. First, agentic abilities. That's the key to letting the model actually do things, use tools, interact with the world, not just spit out text. It's about orchestrating actions.
Okay, so agentic is about doing. Then there's complex reasoning. That's not just finding facts, right? It's solving multi-step problems like math, science.
Exactly. Logical deduction, structured problem solving, often needing multiple steps. And the third piece is advanced coding. Not just writing simple scripts, but tackling, real software engineering challenges, debugging, maybe even contributing to big projects. And the interesting thing they point out is, proprietary models have hit home runs in maybe one or two of these ART areas. But a single open source model that nails all three, that's been missing.
Until now, they argue. So GLM 4.5 is aiming to fill that gap.
Precisely.
So how did they actually build something that performs so well on ARC and stays efficient? Sounds like the secret sauce is in the architecture and this multi-stage training they use. We mentioned the models, GLM 4.5, 355 billion total, 32 billion active, and the smaller Air version, 106 billion. And that hybrid reasoning switching between thinking slow and fast.
Yeah, and a huge innovation is that this is the first mixture of experts model in their GLM series. That MoE architecture is key for computational efficiency, both training and running the model. They use clever tricks like loss-free balance routing too. Basically, it smartly sends tasks to the right expert part of the model without wasting compute. Makes the whole thing leaner.
And I thought their choice to go deeper rather than wider was really interesting. They cut back on the width, like the hidden dimension, but seriously cranked up the number of layers.
Right. They found deeper models just had better reasoning power. It's maybe not the first thing you'd think of, but the results seem to back it up.
Makes sense. And they didn't stop there with the architecture, did they? Attention enhancements too.
Oh yeah. Grouped query attention with partial row PA. Way more attention heads, like 2.5 times more. Interestingly, they said more heads didn't help training loss much, but consistently boosted reasoning scores. They also used QK norm to stabilize attention, keep it focused. And they baked in support for speculative decoding, with the MoE layer acting as a multi-token prediction layer. Faster inference again.
And looking at their table 1 comparing parameters, wow, GLM 4.5 is way smaller in total parameters than DeepSeek P3 or Kimi K2, which are massive.
Exactly. But comparable activated parameters, it's doing more with less, which is huge for open source accessibility, right? You don't need a national level supercomputer.
Okay, so that's the architecture. What about the training? Sounds intense. Multi-stage, starting with pre-training on 23 trillion tokens.
Yep, 23 trillion. It's a staggering amount. The data was super diverse too. Web pages, English, Chinese, multilingual docs, lots of curated code from GitHub. They were really careful about data quality too, filtering deduplication, using things like Semmed It Up, even using an LLM to score math and science content for quality.
And this pre-training wasn't just one big dump, right? It was 2 stages. General stuff first, then boosting the code, math, science data.
Correct. General foundation first, then specializing. But even after that massive pre-training, they added more stages mid-training for specific boosts.
Ah, okay. Like what?
Well, crucial stuff for ARC. Repo-level code training was one. They basically fed the model concatenated code files from the same software repository. That helps it learn cross-file stuff, how real software projects are structured. They even threw in GitHub issues, PRs, commits, and they pushed the sequence length up to 32K for this.
That sounds incredibly useful for actual coding tasks. What else in mid-training?
Synthetic reasoning data. They took questions from math, science, coding competitions, but then used another model to generate the step-by-step thinking process. A really clever way to create structured reasoning examples.
That is smart, generating the how, not just the what.
And then long context training, pushing the sequence length even further, 128K. Upsampling long docs, adding synthetic agent trajectories. They also tweaked the ROPE base frequency here, adjusting it from 10K to 1 million, which is a known technique to help models handle much longer inputs better, really pushing the context window.
And under the hood, for hyperparameters, they used the muon optimizer. Said it helped convergence and allowed bigger batches.
Yeah, muon optimizer, cosine decay for the learning rate apparently avoided underfitting they saw with other schedules. Batch size warm-up too. No dropout, interestingly. Seems like every detail was optimized.
Okay, so pre-training, mid-training, then comes post-training. This is where the expert model iteration happens.
Right. 2 main stages here. First, expert training. They build separate specialist models for reasoning, agentic tasks, and general chat. Then stage 2 is unified training. They use self-distillation. Basically, the experts teach a single combined model to integrate everything. That's how they get that hybrid reasoning, the ability to be deliberative or quick.
And supervised fine-tuning, SFT, is key here. They started with a cold start SFT using chain of thought to give each expert a baseline. Then the main SFT used millions of samples from these experts' reasoning, chat, agent stuff, long context. Balancing all that seems critical for the hybrid goal.
Definitely. And one really neat detail in the SFT part was their custom function call template instead of standard JSON, which needs tons of character escaping for code.
Oh yeah, I saw that. The XML like tags, like tool call, RKey.
Exactly. It dramatically cuts down on escaping, especially when passing code snippets as arguments. Makes it much easier for the agent model to learn how to call tools correctly. It's a small thing, but really practical.
That makes total sense. And they were rigorous about SFT data quality too, right? Rejection sampling, verifying correctness, using reward models.
Absolutely. Filtering bad samples, checking tool calls, even generating multiple answers for hard prompts to boost performance in areas like math. Quality was paramount. They even automated building the Agentic SFT Data, a 4-step pipeline. Collect tools, synthesize tasks with LLMs, generate trajectories, and then filter for quality using other judge agents. Pretty sophisticated setup.
Okay, moving past SFT to reinforcement learning. First, reasoning RL. They used the GRPO framework and tackled reward variance.
Yeah, GRPO. And the cool part was their difficulty-based curriculum learning. 2 stages. They found that easy data stops being useful, and super hard data gives no gradient signal. So they start with moderately hard problems, then switch to extremely difficult ones in the second stage. Their Fetch 5 shows it keeps improving, where a simpler approach flatlines. Smart curriculum design.
That's a really useful insight. And what about that finding on single-stage RL for long outputs? That seemed counterintuitive.
It was. They found that doing RL directly at a max target length, like 64K tokens, worked better than gradually increasing the length. Shorter RL stages actually made the model forget its long context abilities, irreversibly.
Whoa, so sometimes you just gotta go big right from the start for long context.
Seems like it, for this setup anyway. They also dynamically adjusted the sampling temperature during RL, increasing it for exploration when rewards plateaued, but carefully controlling quality.
And specific RL findings for code and science.
For code RL, using a token-weighted mean loss was key. Faster convergence, more stable gradients helped avoid length bias. For Science RL, especially on tough benchmarks like GPQA Diamond, using only high-quality expert-verified questions gave much better results than mixing in lower-quality data. Data quality again.
Always comes back to the data. Okay, then Agentic RL, leveraging verifiable outcomes like in web search or code execution.
Exactly. Those tasks give you clearer, denser rewards. They build automated pipelines for web search data synthesis, multi-hop reasoning over knowledge graphs, and use GitHub PR issues for software tasks, running code in sandboxes for reliable feedback.
And a harsh penalty for bad tool calls. 0 reward.
Yep, strict format penalty forces the agent to learn the right way to interact. And they use that iterative distillation. Again, RL trains a model. Its outputs are used to improve the SFT model via self-distillation. Then RL resumes on the better SFT model. Keep pushing the boundary.
And they found that just letting the agent interact more with the environment improved performance. Scaling test time compute.
Yeah, Figure 8 shows it clearly for browse comp. More browsing turns, higher accuracy, more interaction helps the agent figure things out.
Makes sense. Okay, last RL bit, general RL. This was about overall improvement and fixing issues.
Right, using multi-source feedback rules, humans, RLHF, and other models, RLAIF, a hybrid approach for robust signals.
They had holistic RL with a big, balanced data set covering lots of categories, and instruction following RL with the super detailed taxonomy of constraint types. Sounds thorough.
Very. They used hybrid feedback here too and seemed to manage reward hacking well.
Function calling RL had 2 parts, stepwise and end-to-end.
Yeah. Stepwise RL used a strict rule, reward of 1 only for perfect format and matching the ground truth. Great for nailing the format. End-to-end RL let the model generate a whole interaction sequence, rewarding based on final task success. Better for learning planning and using tool feedback.
And finally, pathology RL just to stamp out common errors like repetition or bad formatting.
Exactly. Targeted data set to provoke those issues and penalize them effectively. Really polishing the model.
And underpinning all this RL complexity is their open source infrastructure, Slime. Sounds crucial.
Totally. It's designed for flexibility. Collocated synchronous mode for fast reasoning tasks, disaggregated async mode for long agent tasks like coding, keeps GPUs busy even if agent interactions take ages, uses Ray framework.
Plus acceleration, mixed precision, FP8 inference.
Yep, BF16 for training, FP8 for inference rollout, even online FP8 quantization. And it's built for agents' high concurrency Docker runtimes, async loops, unified interface. It's a serious piece of engineering to enable all that RL.
Okay, wow. That is a lot of architectural and training innovation. So after all that, did it work? What do the evaluations say?
They're pretty compelling. Overall performance across ARC benchmarks, GLM-4.5 comes in 3rd among all the models they tested as of late July 2025. The smaller Air version is 6th.
3rd overall is huge for an open source model of this size, and you said it was particularly strong on agentic tasks.
Yeah, number 2 overall on Agentic Benchmarks, just behind OpenAI's O3, which is amazing considering it has like half the parameters of DeepSeek R1 and a third of Kimi K2, really punches above its weight.
Okay, let's break down the ARC results. Agentic abilities.
Solid scores. 70.1% on TAU bench, that's around Claude Sonnet 4 level. Best among baselines on BSCLv3 at 77.8%. And on BrowseCon for web browsing, 26.4%, which actually beat Claude Opus 4. Serious tool use.
Impressive. And reasoning.
Outstanding, really. 91.0% on AP24, that's a tough math competition benchmark. 79.1% on GPQA, 72.9% on LiveCode Bench. It even beat OpenAI O3 on AME24 and SciCode, and on average outperformed Claude Opus 4. Demonstrates real multi-step problem-solving skill.
Wow. Okay, and coding, you said it was a powerhouse here too.
Definitely. 64.2% on SWE Bench Verified. That score beats GPT 4.1 and Gemini 2.5 Pro according to the results. On Terminal Bench, 37.5%, beating Claude Sonnet 4. And then figure 2 in the paper is telling GLM 4.5 and Air are right on the proto frontier for SWE bench score versus parameters. Maximum coding bang for your parameter buck, basically.
That efficiency metric is key. What about just general knowledge, like MMLU or QA?
Competitive there, too.
Yeah.
Interestingly, on simple QA, which is mostly factual recall, it performs similarly to the much larger DeepSeek models, V3 and R1, both 671B params. So it holds on to general knowledge well, despite being smaller, a true generalist.
And safety, always important.
It scored well, 89.87 on safety bench, which is up there with Kimi K2 and GPT 4.1. Showed good robustness on ethics, mental health, physical health questions. Seems responsibly trained.
Good to hear. Now, they didn't just rely on benchmarks, right? Human evaluations, too.
Yeah, they did extensive human evals. For general chat, across English, Chinese, other languages, GLM 4.5 got the highest overall scores from human judges on diverse prompts, math, tech stuff, coding instructions. Humans liked it.
And the coding agent specifically, how did humans rate that?
They used CC Bench 52, real programming tasks run in sandboxes. Head-to-head, GLM 4.5 beat Kimi K2 over half the time, 53.9% win, and crushed Qwen 3 Coder, 80.8% win. Very competitive with Claude Sonnet 4 too. And crucially, it had the highest tool calling success rate at 90.6%. That reliability is vital for agents actually doing complex coding work.
Makes sense. You can't have an agent failing half the time it tries to use a tool. Did they test other reasoning too?
Yep, they made a new set of tricky logical reasoning problems designed to avoid data contamination from existing benchmarks. GLM 4.5 performed competitively there as well. But maybe the most surprising human evil result was translation.
Oh yeah, better than specialized translation models.
Significantly better, according to their tests on 100 really hard real-world cases. Stuff involving internet slang, cultural nuances, specific jargon.
Like what examples?
Things like correctly getting yards as eternal god, recognizing peng as a nickname for a camera lens in Chinese photography forums, understanding the fish emoji means the Xianyu online marketplace, or translating, not just literally, but capturing the playful tone as the calico princess has arrived. That shows really deep contextual and cultural understanding, not just word mapping. It hints at, like, genuine intelligence.
That's fascinating. Okay, so wrapping up, what's the big takeaway here for listeners?
I think GLM 4.5 is a major milestone for open source LLMs. It really delivers on unifying those critical ARC capabilities, agentic, reasoning, coding, and does it with impressive parameter efficiency. It's a truly capable generalist model.
Yeah, feels like it really pushes the boundary of what open models can do.
Absolutely. And this release just opens up so many possibilities for researchers and developers. It strongly challenges the idea that you need access to closed source behemoths for cutting edge ARC performance. It's great for the whole ecosystem.
So a final thought for everyone listening. As these models, like GLM 4.5, get better and better at acting, reasoning, coding, what new doors does that open for you, for the AI applications you're building or dreaming of?
And maybe, how will powerful open source models like this continue to shape the path towards HGI? How fast will things move now?
Definitely something to think about. If you want to dive deeper yourself, remember everything. The paper, the code, the models is out there.
Yep, check GitHub, Hugging Face, Z.ai, BigModel.cn. All the nitty-gritty details on the architecture, the training stages, the evils are in the paper.
Fantastic. Well, that's our look at GLM 4.5 for today. Thanks for tuning in to AI Paper Podcasts.
See you next time.